Dear students, welcome. We are solving problems on the nth derivatives. This chapter is included in the first BSc first semester honors. Let us take some more problems. Find the nth differential coefficient of. Find the nth differential coefficient of 1 by x square plus a square. Let y equal to 1 by x square plus a square. 1 equal to 1 by x square plus a square. This can be written as x plus ia into x minus ia. This can be written as x plus ia into x minus ia. Resolving into partial fraction, you will get this one. Now differentiating n times, we get n times, we get. Now differentiating n times, we get yn, this is equal to 1 by twice ia. What is the differentiation, nth differentiation of this? Ax plus b whole to the power n, the ax plus b whole to the power minus 1, the nth differentiation is minus 1 whole to the power n factorial n divided by ax plus b whole to the power n plus 1. Of course, into a to the power n. Here you will get minus 1 whole to the power n factorial n divided by x minus ia whole to the power n plus 1 minus, for this you will get minus 1 whole to the power n factorial n x plus ia whole to the power n plus 1. You will get this. Now take minus 1 whole to the power n factorial n common. You will get 1 by x minus ia whole to the power n plus 1 minus 1 by x plus ia whole to the power n plus 1 whole to the power n plus 1. You will get this. Suppose this is number 1. Suppose this is number 1. Now put x equal to r cos phi, y this is equal to r sin phi. Therefore tan phi, well, not y, this is a equal to r sin phi. Therefore tan phi equal to a divided by x. This means phi equal to tan inverse a by x. Phi this is equal to tan inverse a by x. You will get this one. Therefore 1 implies yn, this is equal to minus 1 whole to the power n factorial n divided by twice ia. 1 by, for x put r cos phi minus I r sin phi whole to the power n plus 1 whole to the power n plus 1 whole to the power n plus 1, and it is minus 1 by r cos phi plus I r sin phi whole to the power n plus 1 whole to the power n plus 1. You will get this. Now r to the power n plus 1 in the denominator will be common from the denominator, r to the power n plus 1. It is common. It can be taken outside. 1 by cos phi minus I sin phi whole to the power n plus 1 minus 1 by cos phi plus I sin phi whole to the power n plus 1. This is equal to minus 1 whole to the power n factorial n twice IA r to the power n plus 1 cos phi minus I sin phi whole to the power minus n plus 1 minus cos phi plus I sin phi whole to the power minus n plus 1 whole to the power minus n plus 1 whole to the power minus n plus 1. Now we shall apply de Moivre's theorem. The de Moivre's theorem states that whatever be the value of n, positive or negative, rational or integral, the value or one of the values of this is cos n phi plus I sin n phi. N may be positive or negative, rational or integral. If it is rational, one of the values of this will be cos n phi plus I sin n phi. Now, this is equal to, therefore yn, this is equal to minus 1 whole to the power n factorial n divided by twice IA r to the power n plus 1. You may write it as cos n plus 1 phi cos minus theta is equal to plus cos theta. Therefore, I am writing here this plus I sin n plus 1 theta n plus 1 phi. I sin n plus 1 phi minus cos n plus 1 phi. It will be again minus and minus, it will be plus. I sin n plus 1 phi. By de Moivre's theorem, we get this. By de Moivre's theorem, we get this. Now, these two terms will be cancelled. Finally, you will get yn, this is equal to minus 1 whole to the power n factorial n divided by twice IA. For r, a equal to r sin phi. For r, you may write a by sin phi whole to the power n plus 1 into twice I sin of n plus 1 phi. Sin of n plus 1 phi. Twice I will be cancelled. This is equal to minus 1 whole to the power n factorial n divided by a to the power n plus 1 into a to the power n plus 1 into a, it will be a to the power n plus 2, a to the power n plus 2, and it will be sin to the power n plus 1 phi sin of n plus 1 phi n plus 1 pi. Here you may write, since a this is equal to r sin phi, therefore r equal to a by sin phi. You may write here, and where phi equal to tan inverse a by x. Tan inverse a by x. Now see, yn equal to minus 1 whole to the power n factorial n divided by a to the power n plus 2. In this form, we can find the nth derivative of 1 by x square plus a square. Let us take another example. If y equal to tan inverse x by a, find yn. Find the nth derivatives of tan inverse x by a. Find the nth derivatives of tan inverse x by a. Solution. Y this is equal to tan inverse x by a. This means y1, differentiating 1 with respect to x. You will get this into 1 by a. This is equal to a divided by x square plus a square, which can be written as a divided by x plus ia into x minus ia x plus ia into x minus ia. This means y1, this is equal to 1 by twice I, 1 by x minus ia minus 1 by x plus ie. I can write like this. I can write like this. Now suppose this is number 1. To find, this is y1. To find yn, we have to differentiate 1 with respect to x n minus 1 times. Then we will find yn. Differentiating 1, n minus 1 times, we get, with respect to x, we get yn, this is equal to 1 by twice I. If you differentiate it n minus 1 times, you will get minus 1 whole to the power n minus 1 factorial n minus 1 divided by x minus ia whole to the power n minus 1 whole to the power n minus 1 factorial n minus 1 divided by x plus ia whole to the power n. You will get this. Now this means yn, this is equal to minus 1 whole to the power n minus 1 factorial n minus 1 divided by twice I. Here you may write x minus ia whole to the power minus n minus x plus ia whole to the power minus n. You may write like this. Suppose this is number 2. Put x equal to r cos phi. Y this is equal to r sin phi. Put x is equal to r cos phi, y is equal to r sin phi. So that tan phi, it is not y, this is a. We have to put x is equal to r cos phi, this is a equal to r sin phi. X is equal to r cos phi, a equal to r sin phi. So that tan phi, this is equal to a by x. This means phi, this is equal to tan inverse a by x. Phi equal to tan inverse a by x. Therefore 2 implies yn, this is equal to minus 1 whole to the power n minus 1 factorial n minus 1 divided by twice I for x r cos phi minus I r sin phi whole to the power minus n minus r cos phi plus I r sin phi whole to the power minus n. You may write like this. This is equal to minus 1 whole to the power n minus 1 whole to the power n minus 1 factorial n minus 1 divided by twice I r to the power minus n cos phi minus I sin phi whole to the power minus n minus cos phi plus I sin phi whole to the power minus n whole to the power minus n. R to the power minus n. This is equal to minus 1 whole to the power n minus 1 factorial n minus 1 twice I r to the power n cos n phi, it will be plus I sin n phi minus cos n phi again plus I sin n phi by De-Moivre's theorem. By De-Moivre's theorem, we get this. Now, these two terms will be cancelled. This is equal to minus 1 whole to the power n minus 1 factorial n minus 1 twice I. You see, a, this is equal to r sin phi. Therefore, r equal to a by sin phi. Whole to the power n. It will be twice I sin n phi. Since a, this is equal to r sin phi. This means r, this is equal to a by sin phi. R, this is equal to a by sin phi. Twice I cancel. Twice I cancel. This means yn. This is equal to minus 1 whole to the power n minus 1 factorial n minus 1 divided by a to the power n divided by a to the power n sin to the power n pi sin n pi, where pi equal to tan inverse a by x. Pi, this is equal to tan inverse a by x, right? Now, if y, this is equal to tan inverse twice x by 1 minus x square, find yn. If y, this is equal to tan inverse twice x by 1 minus x square, find yn. Y, this is equal to tan inverse twice x divided by 1 minus x square. This is nothing but twice tan inverse x. This is twice tan inverse x. This will be twice tan inverse x. Therefore, y1, this is equal to 2 divided by x square plus 1. This is equal to 2 divided by x plus I into x minus I. This is equal to 2 into 1 by twice I. 1 by x minus I minus 1 by x plus I. I can write like this. This is equal to 1 by I. 1 by x minus I minus 1 by x plus I. Or simply you may write it as 1 by I x minus I whole to the power minus 1 minus x plus I whole to the power minus 1. You may write like this also. y1 equal to this. y1, this is equal to this. Therefore, y1 is equal to 1 by I x minus I whole to the power minus 1 minus x plus I whole to the power minus 1. X plus I whole to the power minus 1. Suppose this is number 1. To get yn, we have to differentiate 1 n minus 1 times. Differentiating 1 n minus 1 times we get. Differentiating 1 n minus 1 times we get yn equal to 1 by n. It will be minus 1 whole to the power n minus 1 factorial n minus 1 x minus I whole to the power n minus minus 1 whole to the power n minus 1 factorial n minus 1 divided by x plus I whole to the power n minus 1 times. If you differentiate n minus 1 times, this means yn, this is equal to minus 1 whole to the power n minus 1 factorial n minus 1 divided by I x minus I whole to the power minus n minus x plus I whole to the power minus n whole to the power minus n. Suppose this is number 2. Suppose this is number 2. Now put x equal to r cos phi Here we have to put 1 equal to r sin phi. 1, this is equal to r sin phi. Put x is equal to r cos phi, 1 is equal to r sin phi. This means tan phi equal to 1 by x. Means phi equal to tan inverse 1 by x. Or cot inverse x. Tan inverse 1 by x or cot inverse x. Phi equal to tan inverse 1 by x. Therefore, from 2, therefore 2 implies. Therefore 2. This implies ym, this is equal to minus 1 whole to the power n minus 1 factorial n minus 1 divided by I. For x, write r cos phi minus I r sin phi whole to the power minus n minus r cos phi plus I r sin phi whole to the power minus n. Whole to the power minus n. This is equal to minus 1 whole to the power n minus 1 factorial n minus 1 divided by I r to the power minus n. Here cos phi minus I sin phi whole to the power minus n minus cos phi plus I sin phi whole to the power minus n. Right? This is equal to minus 1 whole to the power n minus 1 factorial n minus 1 divided by I into r to the power n cos n phi plus I sin n phi minus cos n phi plus I sin n phi. I sin n phi. I sin n phi. These two terms will be cancelled. This is equal to minus 1 whole to the power n minus 1 factorial n minus 1 1 equal to r sin phi. Therefore r is equal to 1 by sin phi whole to the power n. It will be twice I sin n phi. Since 1 this is equal to r sin phi. 1 this is equal to r sin phi. This is equal to 2 times of minus 1 whole to the power n minus 1 factorial n minus 1 I will be cancelled sin to the power n phi sin n phi sin to the power n phi sin n phi, where phi equal to phi this is equal to tan inverse 1 by x. Phi this is equal to tan inverse 1 by x. Therefore nth differentiation is this. In such way we can find the nth differentiation. Next problem, if suppose it is number 4, today's if y equal to tan inverse root over 1 plus x square minus 1 divided by x, find yn. Find yn. Find yn. Now put x, this is equal to tan phi, tan theta. Suppose this is equal to tan theta. This means y equal to tan inverse root over 1 plus tan square theta minus 1 divided by tan theta. Divided by tan theta. This is equal to tan inverse sec theta minus 1 divided by tan theta. This is equal to tan inverse multiply numerator and denominator by cos theta 1 minus cos theta divided by sin theta. And this will be equal to tan inverse twice sin square theta by 2 divided by twice sin theta by 2 into cos theta by 2. We can write like this, divided by this. This is equal to tan inverse tan theta by 2. Tan inverse tan theta by 2. This is equal to half of theta. This is equal to half of, what is theta? Theta will be equal to tan inverse x. Theta is equal to tan inverse x. Therefore y theta is equal to tan inverse x. Therefore, why this is equal to tan inverse root over 1 plus tan square theta 1 plus x square minus 1 divided by x. This is equal to half of tan inverse x. Tan inverse x. In the previous question, we found the nth derivatives of tan inverse x. We found the nth derivatives of tan inverse x. We found that tan inverse twice x divided by 1 minus x square. This is equal to twice tan inverse x. In the previous example, we found the nth differentiation of this, and we found that it will be 2 times of this one, 2 times of this one. Therefore, if twice tan inverse x, nth differentiation of twice tan inverse x is equal to 2 times of minus 1 whole to the power n minus 1 factorial n minus 1 sin to the power n phi sin n phi, where phi equal to tan inverse 1 by x or cot inverse x. Therefore, half of tan inverse x, therefore yn equal to, it will be half, and other terms will be as it is, factorial n minus 1 sin to the power n phi into sin n phi, where phi equal to cot inverse x. Just as the previous example, or as the previous example. And this will be the answer of this. Y is equal to this, it will be half of tan inverse x. The nth differentiation will be proceeding as the previous example, we get this. Suppose another problem. If y equal to tan inverse 1 plus x divided by 1 minus x, find yn. Suppose you are asked to find the nth differentiation of tan inverse 1 plus x divided by 1 minus x. Then what will be yn? Here y equal to tan inverse 1 plus x divided by 1 minus x. This is equal to tan inverse 1 plus x divided by 1 minus 1 into x. You may write like this: 1 plus x divided by 1 minus 1 into x. Tan inverse a plus tan inverse b. This is equal to tan inverse a plus b divided by 1 minus ab. It is of the form tan inverse a plus b divided by 1 minus a into b. It will be definitely tan inverse 1 plus tan inverse x. The differentiation of tan inverse 1, this is equal to 0. It is pi by 4. This is equal to 0. Tan inverse x, the nth differentiation of tan inverse x will be what? Therefore, yn will be equal to. Definitely yn will be equal to minus 1 whole to the power n minus 1. Yes. Minus 1 whole to the power n minus 1. Factorial n minus 1. Sin to the power n phi sin n phi, where phi equal to tan inverse 1 by x, where phi equal to tan inverse 1 by x. Let us take another example. If y, this is equal to x square plus x square whole to the power minus 1, then find y. Y equal to x divided by, it is x square plus x square. This is equal to x divided by x plus IA. into x minus I. This is equal to 1 by 2. It will be this. It will be like this. Y. Therefore, Ym, this is equal to 1 by 2 times the nth differentiation of this will be equal to minus 1 whole to the power n. We will have to remember this. Divided by x minus ia whole to the power n plus 1 plus minus 1 whole to the power n factorial n x plus ia whole to the power n plus 1. You will get this one. Obviously you will get this. This is equal to half of minus 1 whole to the power n factorial n 1 by x minus ia whole to the power n plus 1 minus, it is plus 1 by x plus ia whole to the power n plus 1. It will be like this. Or you may write like this also, minus 1 whole to the power n factorial n x minus ia whole to the power minus n plus 1 plus x plus ia whole to the power minus n plus 1. N plus 1. It is raining outside. Now, why am I doing this? Why am this is equal to? Suppose this is number 1. Suppose this is number 1. Put x equal to r cos phi. A, this is equal to r sin phi. Put x is equal to r cos phi. A equal to r sin phi. This means tan phi. This is equal to a by h. This means phi equal to tan inverse a by h. Phi equal to tan inverse a by h. Therefore, 1 implies from 1 you will get Ym, this is equal to half minus 1 whole to the power n factorial n. It will be r cos phi minus I r sin phi whole to the power minus n plus 1 plus r cos phi plus I r sin phi whole to the power minus n plus 1 minus n plus 1. This is equal to 1 by 2 minus 1 whole to the power n factorial n r to the power minus n plus 1 and in the bracket you will get x minus I sin theta sin phi whole to the power minus n plus 1 plus cos phi plus I sin phi whole to the power minus n plus 1 whole to the power minus n plus 1. It is raining outside, therefore minus 1 whole to the power factorial 1 by r to the power n plus 1. By the Moivre's theorem, you will get cos n plus 1 phi. It will be derivative plus I sin n plus 1 phi. Plus cos n plus 1 phi and it will be minus I sin n plus 1 phi. Sin n plus 1. It will be, these terms will be cancelled in this case. In this case, these terms will be cancelled. This means Ym, this is equal to half minus 1 whole to the power n factorial n 1 by, it will be a divided by sin phi whole to the power n twice cos n plus 1 pi. Since a, this is equal to r sin pi. From this we have put the value of r. This means yn, this is equal to half minus 1 whole to the power n factorial n divided by a to the power n into 2. This 2 cancel, will be cancelled. This 2 will be cancelled. A to the power n sine to the power, no, a to the, it is n plus 1, not n, it is n plus 1. A divided by sine phi whole to the power n plus 1. It is n plus 1. Sine to the power n plus 1 pi cos n plus 1 pi, where pi will be tan inverse a by h, where pi this is equal to tan inverse a by h. Pi this is equal to tan inverse a by h. This is the nth derivatives of this. This is the nth derivatives of this. Perhaps you understand this. Very easy. It is not tough. Very easy. Now take another type of example. Now let us take another type of example. If I am, this is equal to d to the power n dx to the power n x to the power n log x, x to the power n log x, then show that x to the power n log x, then show that I am, this is equal to n minus 1 n times of I n minus 1 plus factorial n minus 1. I n is equal to n times of I n minus 1. Hence show that means we have to apply this result. We have to apply this result. Hence show that I am, this is equal to factorial n log x plus 1 plus 1 by 2 plus 1 by 3 plus dot 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 plus 1 by n minus 1 plus 1 by n plus 1 by n. This is the question. Solution. I am equal to d to the power n by dx to the power n log x. I am equal to d to the power n dx to the power. This can be written as dx to the power n minus 1 dx x to the power n log x. Can I write like this? D to the power n minus 1 dx to the power n minus 1 ddx of x to the power n log x. Can I write like this? This is equal to d to the power n dx to the power d to the power n minus 1 dx to the power n minus 1. Differentiation of these n x to the power n minus 1 log x plus x to the power n differentiation of log x is 1 by x. Log x is 1 by x. This means I am equal to d to the power n minus 1 by dx to the power n minus 1. And you may write here n into this. You may write here n into this. x to the power n minus 1 log x, x to the power n minus 1 log x, plus d to the power n minus 1 dx to the power n minus 1 x to the power n minus 1 x to the power n minus 1. We may write like this. Now notice that this is equal to d to the power n dx to the power n x to the power n log x. The nth differentiation of x to the power n log x is represented by Then in this case we have replaced n by n minus 1. Also it has also been replaced by n minus 1, n minus 1. N is replaced by n minus 1. In this case n is replaced by n minus 1. If this is equal to what will be this? Definitely in minus 1. Definitely it will be in minus 1. In minus 1 plus what will be the nth differentiation of this? What will be the nth differentiation of this? Suppose x square 2 times differentiate it 2 times. First time 2 into x, second time 2 into 1. This is equal to factorial 2. Differentiate x cube 3 times. It will be what? If you differentiate it 3 times, it will be 3 into 2 into 1. This is equal to factorial 3. This is equal to factorial 3. If you differentiate x to the power n times, then d to the power n dx to the power n times, then the n times differentiation will be n into n minus 1, n minus 2, 3 to 1, which is equal to, this is equal to factorial n. This is equal to factorial n. Now you see x to the power n minus 1. If you differentiate x to the power n minus 1 times, then what will be the result of this? Factorial n minus 1. Factorial n minus 1. The first part has been proved. Not answer proved. First part has been proved. It has been proved. The first part has been proved. Now we are going to find the second part. Second part. We are going to prove the second part. Second part. We are going to solve the second part. Second part is given that we have just proved. We have just proved. Proved that. We have just proved that. This is equal to n minus 1 plus factorial n minus 1. Suppose this is number 1. We have just proved this. Now divide this by factorial n. Dividing 1 by factorial 1 we get. Dividing 1 by factorial n we get. Dividing 1 by factorial n we get. Divided by factorial n. This is equal to n minus 1 by factorial n plus factorial n minus 1 by factorial n. Both sides we have divided both sides of 1 by factorial. We have divided both sides of 1 by factorial n. Now this means n by factorial n. This is equal to n times of n minus 1. Factorial n can be written as n into factorial n minus 1 plus n minus 1 factorial. This factorial n can be replaced by n into factorial n minus 1. This means n by factorial n. This is equal to n minus 1 by factorial n minus 1 plus 1 by n plus 1 by n. Right? Suppose this is number 2. Now replacing n by, now replacing n by n minus 1 into we get, replacing n by n minus 1 into we get I n minus 1 by factorial n minus 1. This is equal to I n minus 2 by factorial n minus 2 plus 1 by n minus 1. Am I right? Now substitute the value of this into we get. Substitute this value into we get. Therefore 2 implies, you may write here 2 implies I n by factorial n. This is equal to, replace this by this, I n minus 2 by factorial n minus 2 plus 1 by n minus 1 plus 1 by n plus 1 by n plus 1 by n, right? This, suppose this is number 3. Suppose this is number 3. Now replace n by n minus 2 into, now replacing n by n minus 2 in 2 we get, into we get n by n minus 2 into we get, into we get. Thus we have n by n minus 2. What was our 2? I am divided by factorial n. This is equal to I n minus 1 by factorial n minus 1 plus 1 by n. It was our 2. Replace n by n minus 2 in 2. I n minus 2 divided by n minus 2 factorial n minus 2. This is equal to, replace I n by I n minus 2, n minus 3 by factorial n minus 3. You will get n minus 3 divided by factorial n minus 3 plus 1 by n minus 2 plus 1 by n minus 2. Now substitute this value in 3 we get. Substitute this value, substitute this value means this is equal to this in 3. Therefore 3 implies. From 3 you will get I n by factorial n. This is equal to, for this you put I n minus 3 by factorial n minus 3 plus 1 by n minus 2 plus 1 by n minus 1 plus 1 by n plus 1 by, again you may again replace, replacing n by n minus 3 into we get I n minus 3 by n minus 3 factorial. This is equal to I n minus 4 by n minus 4 factorial plus 1 by n minus 3. 1 by n minus 3. Suppose this is number 4. Therefore 4 implies I n by factorial n. This is equal to I n minus 4 by factorial n minus 4 plus 1 by n minus 3 plus 1 by n minus 2 plus 1 by n minus 1 plus 1 by n. Am I right? Now proceeding in this way we will get, proceeding in this way. Proceeding in this way, we shall ultimately gain. Proceeding in in this way, we shall ultimately get. What we will get? Left hand side is ion by factorial n. Left hand side, there is no change in the left hand side. Ion by factorial n. Ion by factorial n. This is equal to, in all cases, you see 1 by n, 1 by n minus 1, these terms are all common. We shall ultimately get. I am writing from the right side. 1 by n. 1 by n plus the term before 1 by n. The term before n plus 2. n minus 2. Plus dot dot dot. These terms occur in all terms. 1 by n occurs in all terms, like this. And you see here, ultimately, you will get, when n is equal to 5, suppose, put n is equal to 5 here. If you put n is equal to 5, what will you get? I1 by factorial 1. Therefore, you will get I1 by factorial 1. Here you will get I1 by factorial 1. What we have put here? N is equal to 5. We have put n is equal to 5. Therefore, put n is equal to 5 in here also. If you put n is equal to 5, 1 by 5 minus 3 equal to 1 by 2. Next term will be 1 by 2 plus n is equal to 5, put 1 by 3 plus 1 by 4 plus 1 by 2 plus 1 by 5 plus dot dot dot. Right? We will get ultimately this. We will get ultimately this term. Perhaps you understand this one. Now, suppose this is number, I am writing it here. Now, I am equal to d to the power n, dx to the power n, x to the power n log x. I am is equal to this. I am equal to d to the power n, x to the power n log x. Therefore, I want equal to d dx of, put n is equal to 1 here also, x log x. It will be definitely x log x. I1 will be equal to definitely this. I1. In the left hand side we have put n is equal to 1. In the right hand side also you will have to put n is equal to 1. d dx of x log x. This is equal to x into 1 by x plus log x. This is equal to 1 plus log x, which can be written as log x plus. Log x plus. Therefore, substitute I1 equal to log x plus 1 in A. I1 equal to log x plus 1 and factorial 1 means 1. 1 in A we get. In A we get. In A we get. I am by factorial n. This is equal to log x plus 1 plus next term is 1 by 2 plus 1 by 3 plus 1 by n minus 2 plus 1 by n minus 1 plus 1 by n plus 1 by. This means I am equal to factorial n. Log x plus 1 plus 1 by 2 plus 1 by 3 plus 1 by n minus 1 plus 1 by n. Good. Good. In this way, we can we solve the problems of nth differentiation. Dear students, I am very sorry today because it is raining outside. In the next class, we shall meet again, and perhaps in the next class we shall discuss about Leibniz theorem in respect of energy derivatives. First give the statement of the Leibniz theorem, then we prove the Leibniz theorem, then we shall apply the Leibniz theorem in the next class. Thank you very much. Thanks for attending the class. Thank you.